Chapter 4, Force System Resultants. All right, everyone. Today, we are going to talk about something fun. How forces not only push or pull, but also make things twist or spin. Think of when you use a wrench to open a jar lid or a bolt. You are not just pushing it in one straight direction, you are twisting it around. This twist or turning effect is called a moment. Just like you need to push harder or use a longer stick to open a tight lid, the bigger the force or the longer the handle, the stronger the moment. Let's make it easy. Imagine you have a seesaw. If you sit far from the middle and push down, it turns easily. That's because your force has a big moment arm, which is just a fancy way of saying the distance between you and the turning point. If you sit close to the middle, it's much harder to turn. Engineers always think about two things when talking about moments: how much you push and how far from the center you push. Moments have directions too. If you turn your right hand in the direction of the spin, your thumb will point in the direction of the moment. We call this the right hand rule. When something turns counterclockwise, we say it's positive. And when it turns clockwise, it's negative. When we have many forces acting on something, like several people pushing on a door, we can add up all their moments to see which way the door will turn. This is called the resultant moment. We can do it simply by counting all the little turning effects and adding them together, positive or negative. Sometimes we use something called a cross product, which is a clever math trick using vectors. It helps when things are not in a flat playground, but in a 3D world. The cross product helps us know how much turning happens in complicated directions. We always use the right-hand rule to know which way the twist goes. There's also a helpful rule called Varignon's theorem. It says if you split a big push into smaller pushes, the total twisting effect stays the same. Just like pulling a rope at an angle is the same as pulling sideways and upwards together. You can check the twisting effect from both directions, and they will add up to the same total spin. Sometimes we don't want to know all the spinning, but just how much spin happens around a certain direction, like when you turn a key and it only spins around its own axis. To find this, we measure how far the force line is from the axis and multiply by how much we push. Or we can use a triple product, which is a slightly fancier math way to get the same answer. To wrap it up, moments help us understand how forces make things twist or stay balanced. Engineers always look at how much force there is, how far it acts from the center, and which way it makes things spin. Using moments, we can design safe buildings, easy-to-turn doors, and strong bridges that don't fall over. Just like you would think carefully before building a tower of blocks, we think carefully about moments to make sure everything stays balanced and safe.